In this screencast, we're going to focus on the hormones growth hormone and prolactin. I also want to take a moment to remind you that for every hormone that we cover, you must know the following: the organ or tissue that releases that hormone, the location in general of that organ or tissue, the target organ or tissue of the hormone, what stimulates its secretion, its effects on the target organ or tissue, its chemistry and mechanism of action. That is it steroidal or non-steroidal? Does it work directly on the DNA or does it work through second messenger systems? And lastly, its regulation of secretion. Is it positive feedback, negative feedback, or neither?
In this screencast, you will achieve the following objectives: describe the hypophyseal portal system, and then we will discuss two hormones released by the anterior pituitary gland, growth hormone and prolactin. Previously, we discussed the posterior pituitary gland and the two hormones that are produced by neurosecretory cells in the hypothalamus and then secreted from the axon terminals of those cells in the posterior pituitary gland. Those two hormones were oxytocin and antidiuretic hormone. We're now going to turn our attention to the anterior pituitary gland and the hormones that it releases. Let's start our discussion by describing the hypophyseal portal system. So first, what is a portal system? A portal system is a network of veins that carries blood from one capillary bed to another capillary bed. Now, without getting into too much detail, there are three types of blood vessels. You have arteries that carry blood away from the heart toward blood capillaries. You have blood capillaries that then allow the exchange of substances in the blood of those capillaries and the surrounding tissues. You then have veins that carry blood from the capillaries back to the heart. With a portal system, you have veins that connect one capillary bed to another. And this specific capillary bed, this specific network of veins is called the hypophyseal portal system. You have a capillary bed in the infundibulum, and then you have these portal veins, which then carry blood from those capillaries to a second capillary bed in the adenohypophysis. And then veins take blood back to the heart. Now, what is the significance of this portal system? Well, here in this capillary bed, you have axons extending from neurosecretory cells in the hypothalamus. These cells release hormones into the blood of these capillary beds. These hormones are then taken to the second capillary bed in the adenohypophysis, where those hormones then have access to target cells here in the adenohypophysis. These hormones released by the hypothalamus into the hypophyseal portal system, then released into the adenohypophysis, cause the release of other hormones from the adenohypophysis. So in other words, hormones released by the hypothalamus stimulate the release of hormones from the anterior pituitary gland or adenohypophysis. There are four hormones released by the hypothalamus that enter the hypophyseal portal system and act on the anterior pituitary gland or adenohypophysis. All of these hormones are releasing hormones, or in other words, they stimulate the release of hormones from the anterior pituitary gland. That means they are tropic hormones. Remember, a tropic hormone is a hormone that targets other endocrine organs or tissues, causing the release of hormones from those tissues. These four include gonadotropin releasing hormone, thyrotropin releasing hormone, corticotropin releasing hormone, and growth hormone releasing hormone. And as I mentioned in class, when it comes to hormones, we often have little abbreviations for them rather than writing out the entire word or words for the hormone. Now, the names of these tropic hormones are very descriptive. Gonadotropin releasing hormone stimulates the release of gonadotropins. Thyrotropin releasing hormone stimulates the release of thyroid stimulating hormone, also called thyrotropin. Corticotropin releasing hormone stimulates the release of a hormone called adrenocorticotropic hormone. And growth hormone releasing hormone stimulates the release of growth hormone, all from the anterior pituitary gland. So let's just walk through this in a stepwise manner. The image you're looking at here on the right shows the hypothalamus here with the neurosecretory cells. Here you have the hypophyseal portal system here. So here at 1, you have the neurosecretory neurons, which release the hormone into the capillary bed of the infundibulum. Hormone enters that capillary bed. Then it travels through the portal veins of that portal system into the second capillary bed there. Hormones then pass from that capillary bed into the tissues of the adenohypophysis or anterior pituitary gland, and there they interact with their target cells, causing the release of hormones from those endocrine cells that are in the anterior pituitary gland. So in short, hormones released by the hypothalamus travel to the anterior pituitary gland, bind receptors on glandular cells there, which then release their hormones into the blood. We are now going to discuss in some detail the 6 anterior pituitary hormones that are released by the anterior pituitary gland in response to hormones from the hypothalamus. 4 of the 6 hormones released by the anterior pituitary gland are themselves tropic hormones. In other words, they're going to target other endocrine glands or tissues. For example, one of the hormones released by the anterior pituitary gland is thyroid stimulating hormone or thyrotropin. What does it do? Well, it targets the thyroid gland, causes proliferation of the thyroid gland and the release of thyroid hormones. Because thyroid stimulating hormone targets the thyroid gland and causes the release of hormones from the thyroid gland, it is a tropic hormone. So as I mentioned, there are 6 hormones released by the anterior pituitary gland. 2 do not affect endocrine targets. So in other words, 2 are not tropic, the other 4 are. All 6, however, are secreted by the glandular cells in the adenohypophysis and are released in response to tropic hormones from the hypothalamus. There are 4 characteristics that all anterior pituitary hormones have in common that I want you to remember. First, all anterior pituitary hormones are non-steroidal. That means they work through second messengers. They are all secreted in response to hormones from the hypothalamus. So it is hormonal stimuli that's responsible for the secretion of anterior pituitary hormones. And lastly, all regulation of these anterior pituitary hormones is mostly through negative feedback. So when you're completing your hormones and properties table, really the only differences among these 6 anterior pituitary hormones is the target tissue and what it does. For all the other characteristics, chemistry, mechanism of action, regulation, they're all the same. This image is not in your book, but I think it does a fairly good job of giving you an overview of the 6 hormones that are released by the anterior pituitary gland. We have growth hormone, prolactin, follicle stimulating hormone, luteinizing hormone, thyrotropic hormone, also referred to as thyroid stimulating hormone, and adrenocorticotropic hormone. Notice that growth hormone and prolactin target non-endocrine organs. That is, these target organs do not themselves produce hormones. The other 4 hormones are tropic hormones. They target endocrine organs or tissues that themselves produce hormones. Also, I want to remind you that all of these hormones, these 6 hormones of the anterior pituitary gland, are produced and released in response to hormones from the hypothalamus. Let's now look at our first anterior pituitary gland hormone, growth hormone. Growth hormone is released in response to growth hormone releasing hormone from the hypothalamus.
Growth hormone secreted by the anterior pituitary gland targets many tissues, but especially cartilage, bone, muscle, and fat. It is a very important metabolic hormone in that it stimulates the synthesis of protein from amino acids. Remember that anabolism refers to all the synthesis reactions that occur in the body. So if growth hormone stimulates the synthesis of protein from amino acids, which are smaller molecules, it is anabolic because it promotes anabolism, synthesis reactions. In addition to promoting the synthesis of protein, growth hormone also promotes the lengthening of bones by its impact on the growth of cartilage and bone tissue. Growth hormone has a very important glucose sparing effect. It promotes the utilization of fat as a source of energy rather than glucose and protein. Growth hormone targets adipose tissue, causing the breakdown of fat to be used for energy. The breakdown of fat is called lipolysis, if you remember. It targets the liver, promoting the breakdown of glycogen to release glucose to help maintain blood glucose levels. And in all cells, growth hormone promotes the uptake of amino acids for the synthesis of proteins. So growth hormone helps maintain blood glucose levels while at the same time sparing lean body mass, that is, promoting the building of protein and protein-containing tissues like muscle, while allowing the body to use fat as a source of energy. So promoting lean body mass or sparing lean body mass at the expense of fat. I like to illustrate the effects of growth hormone by sharing some conditions that result from either hypersecretion or hyposecretion of growth hormone. In a juvenile that is still growing, excessive output or hypersecretion of hormone from the anterior pituitary gland results in a condition called gigantism. In a juvenile where the growth plates of the long bones are still active, excessive growth hormone release results in abnormal lengthening or excessive lengthening of both the upper and lower appendages. This, of course, results in an abnormally tall person. This gentleman on the right here is still known as undisputedly the tallest person that ever lived. His name was Robert Wadlow. He's from Illinois, was often referred to as the Giant of Illinois, standing at almost 9 feet tall. Excessive output of growth hormone is usually caused by a tumor on the anterior pituitary gland. So what happens if there's excessive release of growth hormone in an adult? Well, in an adult, the growth plates are not active, so you don't get excessive lengthening of the bone, but bones can still widen. So you get deformation of different bones that is very easily seen on like the bones of the hand, bones of the feet, and the facial bones of the face. This condition is called acromegaly, and again, it's due to excessive widening of bones and some of the connective tissues associated with those bones. What about the opposite situation where you have abnormally low secretion of growth hormone, or what's called hyposecretion of hormone? Well, in a juvenile, if that occurs in a juvenile, what results is a situation called pituitary dwarfism, where you have a person with an abnormally small body size, but all of the parts are proportional. And this is due to the just overall decreased lengthening of the bones of the skeleton due to insufficient stimulation of bone growth by growth hormone. Now let's discuss how growth hormone levels in the blood are regulated. So to review, growth hormone releasing hormone is secreted by the hypothalamus. It targets the anterior pituitary gland that then releases growth hormone into the general blood circulation. As growth hormone levels rise in the blood, they inhibit further secretion of growth hormone by the anterior pituitary gland. In addition, as growth hormone levels rise in the blood, they also inhibit further release of growth hormone releasing hormone by the hypothalamus. Classic negative feedback. Now let's take a moment to talk about the second hormone released by the anterior pituitary gland, prolactin. And its name pretty much says it all. Prolactin targets the mammillary glands of the breast and stimulates and maintains milk production following childbirth. Now, prolactin does not do this alone. It acts in concert with progesterone and the hormone estrogen. Prolactin also temporarily stops ovulation following childbirth. So, obviously, this is the effect in females. What is the effect in males? Well, honestly, we really don't know what the function of prolactin is in males. What we do know is if there is excessive secretion of prolactin, it is associated with increasing risk of erectile dysfunction. Before ending, let's review the learning objectives of the screencast. Be able to describe the hypophyseal portal system And after discussing growth hormone and prolactin, make sure that you know all of the characteristics of these hormones per the hormones and properties worksheet that I distributed to you in class.